light and sound, I wondered what would affect the brightness of glow stick. I hypothesized temperature may affect it. Here's my experiment to see if I'm right. I'm testing a group of glow sticks, all purchased at the same time from the same brand. I'm going to be putting one room temperature for control, one hot water, and some fresh from the freezer. As you can see, the ones from the freezer are glowing, but not very brightly. The ones in the hot water are glowing quite bright, much more than usual. And the ones that are room temperature are glowing, but they're brighter than the ones from the freezer, but they aren't as bright as the ones from the hot water. Now we're going to wait to see which one burns out first. I hypothesize the ones in the hot water run out first, because since they glow brighter, they use up more energy, which means they will probably go first. After an hour, the ones in the warm water have burnt out faster. The ones in the freezers, the ones that were in the freezer are now room temperature, and are glowing much brighter. And the ones that were room temperature are still going. This was quite interesting. How glow sticks work is there's a small vial inside of the container which holds a dye. Is very thin glass and can be broken very easily. On the outside is H2O2, which then mixes with the dye and then creates a colored luminescence. The H2O2, or hydrogen peroxide, mixes with the phenyl oxalate ester, creating light but not heat. This chemical reaction, like most chemical reactions, speeds up in the presence of heat, because heat is how fast molecules move, which means it burns faster.